Welcome to lesson 1B.5, solving quadratics by factoring. Let's start with, we're going to summarize the factoring that we've done so far. We factored with a leading coefficient of 1, and then you practice factoring with a leading coefficient that was not 1. We did that by grouping. We factored special cases, and we're going to practice factoring out a monomial right now. What that's going to lead us to is using factoring to solve a quadratic equation. And it's also going to allow us to find the zeros of a quadratic function. Okay, so let's get started. With how to factor out a monomial. A monomial is an expression that has one term. So what we're looking to factor out of these is one term. So let's start with the first one. If I look at 5x and 20, what do they have in common? Well, they have a 5 that I can factor out of both of them. This one has an x, this one doesn't, so I can't factor out an x. I'm going to factor out the 5. I have x squared left because 5x squared equals 5x squared minus 5 times what gives me 20? Well, 4. Okay, and then I have to ask myself, am I done here? And I'm hoping that everybody notices that this is a special case. This is a perfect square, and this is a perfect square. And there's a subtraction sign in the middle. So this is the difference of two perfect squares. So we can replace that with this. I take the square root of the perfect square, and I take the square root of the perfect square. I have my special case. So I can replace this with this. Okay, we're going to move on and look at the next one. What do I have in common here? Well, this time I have a 2 in common that I can divide into both, and I also have a u in common. So I'm going to factor out a 2u. If I take 2u, what do I multiply by to get 2u squared? U. 2u, if I multiply it times 4, I get 8u. And I can't break that down any more than that, so I'm done. Okay, let's take a look at the next one. I have 6p squared plus 15p plus 9. Well, what jumps out at me right away is I can divide all of those by 3. But I can't divide them all by p, so I can't factor out a p. I can only factor out a 3, so let's do that. So this would be 2p squared, this would be 5p, and that would be 3. All right, so now I want to see, can I factor that? You don't know if you can or not, so let's test it out. I'm going to take my 2 and my 3, my first and my last, and I multiply them together, and I'm looking for factors of 6. So my factors of 6 are 1 and 6, and 2 and 3. And I want those to add up to 5. And nice, right there, they do. They add up to 5. So I'm going to use 2 and 3. Okay, so let's come down here. I'm going to bring down my 3, and I'm just going to put brackets around this whole thing so that I separate it. And I'm going to write my 2p squared, and I'm going to replace this 5p with 2p plus 3p. And I still have plus 3. Okay, so I'm going to do some grouping inside here. I still have my 3 on the outside. Let's put this bracket there to separate it. And I'm going to group these two, and I'm going to group these two. Okay, so what do these two have in common? They have 2's and they have p's. So I'm going to put 2p right here. And inside, I would have 2p times p and 2p times 1. And now I'm going to do the same thing here. What can I factor out? I can factor out a 3. It would be 3 times p is 3p, and 3 times 1. Okay, whoops, I went right off the edge, so sorry. And now I'm going to group them together. So I still have my 3 on the outside. I'm not changing that. I have this 2p here, and I have the 3 there. And I group them together, 2p plus 3. And both of these are multiplying p plus 1. And there you go. And I can't break that down any more than that. So this, I factored out a monomial first, and then I factored by grouping. Okay, we have one more to do on this practice sheet, and that's over here. turn this around, slide it over. And what can we factor out of there? Well, it looks like we can factor out a 4. So I'm going to put a 4 here. X squared plus x minus 1. And then I ask myself, can I break that down at all? So let's try. I'm going to take the last number right there. There's no leading coefficient. If there was, I did multiply this time this, but there isn't. So I'm looking for factors of -1. Well, they're just 1 and 1. Is there any way that I could multiply these two together, meaning one of them would have to be negative and one of them would have to be positive, and I add them together and I get a 1 there? There isn't. So this isn't going to work. So this is not factorable. So I'm done. So I wrote it down here so you can see it clearly. So is it possible to factor every trinomial? No, we just showed that it's not possible to factor this one. And if you can't factor it, then we refer to it as irreducible. So I can't make that any smaller than that. Okay, so what we're going to do now is we're going to try and solve quadratic equations using all of this factoring that we just practiced doing. So notice this just as an expression, it's an equation. There's an equal sign and it's equal to 0. All right, so we're going to first try and factor this. So remember, when we factor something, what do? We start by listing our factors. We're looking for factors of -18. So off to the side, I give myself a little table and say -18 and list my factors. So they would be 1 and 18 and 2 and 9 and 3 and 6. And I think I stopped there. Now I want my factors to add up to a +3. So you can see these two are too far apart. These two are 7 apart. These two are 3 apart, which is nice. So that means if I add the two of them together, I could end up with 3. So I'm going to make this a negative and this a positive. If I add those two together, I get a +3, which is just what I'm looking for over here. So then my factors are x minus 3 and x plus 6, and it's equal to 0. Now remember when we talked about the zero product rule before, we can solve this equation now by just setting this equation equal to 0, and we set this equation equal to 0. I'm going to bring the 3 over to the other side, and I get x is equal to 3. I'm going to move the 6 over to the other side, and I get x is equal to -6. So I just found my answer. And the last thing I always want to do is check my answer and make sure that it works. So let's take a look. How do I check it? I'm going to come back up to this equation. So if I do 3 squared plus 3 times 3 minus 18, is that equal to 0? Let's say this is 9 plus 9 is 18. 18 minus 18, that's 0. That works. Let's see if it works for -6. -6 squared plus 3 times -6 minus 18 equals 0. This is -6 squared is 36. This is 3 times -6, which is -18, minus 18 equals 0. And that's true. Okay, so we just found our solution by using the zero product rule and factoring. And we found a solution to this equation. Okay, let's try doing one that looks a little more complicated. So we're going to work on this one next. So the first thing you should notice here is that it's different because up here we had a 0 in this location. So we could use the zero product rule, but there's no 0 there. So we need to make this 0. So that means we need to move this 3t and the -1,5 to the other side. All right, so I'm going to move 3t. So that means I'm going to line it up on the other side over here by doing -3t. I'm going to move the 5 at the same time. I might as well. Plus 5. I'm going to line it up onto here. Plus 5. If I have 3t minus 3t, that's 0. If I have a -5 plus 5, that's 0. So now I have the 0 on that side. Over here, I have 5 plus 5. 45 plus 5 is 50. I have negative 17 and negative 3 is negative 20t, and I have 2t squared. Okay, so what should jump out at you right away now when you're looking at this is I have a 2, a 20, and a 50. So I could factor out a number, and the number I'm going to factor out is the 2. So I would have t squared plus, here I would have, whoops, how about minus, because there's a negative sign there, minus 10t. And this is 2 times what gives me 50 would be 25 equals 0. All right, so this says 2 times this whole quantity equals 0. So I can divide both sides by 2. I'm going to cancel my 2's, and I'm left with t squared minus 10t plus 25 equals, it's still 0 because 0 divided by 2 is 0. And now I'm just going to factor that. Okay, so let's come over here and make my table. I'm looking at that factor. So I have 25 and 1 and 5 and 5. And I'm looking for two numbers when I add them together give me a negative 10, but when I multiply them give me a 25. So how about if I make both of those negative? Negative 5, negative 5, negative 10. All right, so I think we just found our factors. Okay. If I set this one equal to 0, I get t is equal to 5. If I set this equal to 0, I get t is equal to 5. So I have one answer. And let's test that answer. So again, we're going to come back to the original problem. All the way up here. Okay, let's work with this one right here. So we have 2t squared minus 20t plus 50 is equal to 0. And I say that t is 5. So let's try it. 2 times 5 squared plus 20 times 5 plus 50 is equal to 0. Well, 5 squared is 25 times 2 is 50 plus 20 times 5 is 100. Oops. Look at this right here. Minus. This is the mistake that we all make all the time. So you can see that I did that. I'm going to bring this negative sign down. And this is 100 plus 50 is equal to 0. 50 minus 100 is minus 50 plus 50. And you can see that that equals 0. So it's true. So the answer is 5. So what did we do? We wrote the equation in standard form. So we converted it into standard form. Then we factored it. And then we solved it. And then we checked our answer. The last problem we're going to do is to find the value of x for this rectangle. Now we know to find the area of a rectangle, its length times width is equal to area. Here we have our length is x plus 3, our width is x, and our area is 40. For us to be able to solve this, remember we always want to have a 0 on this side so we can use the zero product rule. So first I'm going to multiply this out, and I would get x times x, or x squared, and x times 3 is 3x, equals 40. So to get a 0 over there, I'm going to subtract 40. And now I have x squared plus 3x minus 40 is equal to 0. And now I think I can factor that, so let's try. I'm going to take my factor here, and I'm going to break it down into 1 and 40, and 2 and 20, and 4 and 8, and let's see, I'm sorry, 5 and 8. So now I'm looking for two numbers that when I add them together give me a 3, and when I multiply them together give me a negative 40. So if I want a positive 3 right there, I'm going to make this positive and this negative. And I add them together and I get a 3. So I just found my two factors. X minus 5, x plus 8 equals 0. All right, if I solve this, I get x is equal to 5. If I solve this, I get x is equal to negative 8. And now I'm going to have to plug those in and see which one works.